In the previous video, in the form of a block diagram, we showed you our two branches or buses, one for the power company and one for the generator. We will now show you how we handle the presence or absence of power company voltage, and will give you a schematic view in greater detail, showing the action of the contactors which drive the compressors through the step-down transformers whenever power company voltage is present. On the other hand, we will see in more detail the way in which the time delay relays work on the generator bus, in order to fulfill their function of staggering the starting times of the various loads, so as to avoid overloading the generator when starting several loads at the same time. We will also see the addition of a 3-pole switch, which is used when for maintenance reasons it becomes necessary to start and stop the generator without interfering with the rest of the system. The step-down transformers have their primaries permanently connected in series to the 260-volt alternating current bus line that comes from the power company. The secondaries of these transformers, wired in parallel, are connected in such a way that the voltage they deliver is subtracted from the power company line voltage, in order to deliver a more appropriate voltage to each compressor. This is achieved by means of a contactor which connects the output of its corresponding voltage reducer. Only power company line is live. For each of the loads, a pair of step-down transformers and a contactor are used, which act independently for each of the loads. As for the generator output bus, it also has a contactor for each compressor, which is activated only when the generator is running. This contactor receives 220 volts of alternating current through a time delay relay, thus delaying the moment its associated compressor can start. An independent time delay relay and contactor are used for each compressor, so that the starting time of the various loads can be separately adjusted. This brief truth table shows the logic states of the different voltages and closed contacts, detailing the operation starting with the circuit breakers turned off, thus simulating a blackout. Then after turning the breakers on, simulating power company AC is back, the reset button is pressed, which locks the RY1 contactor, thus feeding power company voltage to the corresponding bus. The next step is when a blackout occurs, with which RY1 is released, being totally insensitive to any temporary flashback of the power company voltage. The next step is to manually start the power generator. When the generator is running, it starts generating AC power, so the RY2 relay, whose contacts were closed up to now, delivers a 0, disabling the reset button, so that it is not possible to close and interlock the RY1 contactor again, thus avoiding a short circuit of the generator with the power grid. When there is 220-volt alternating current voltage being delivered to the generator bus, the staggered loads begin to turn on, one by one, according to the time set by their corresponding time delay relays. Eventually, all the loads will be running, so they all are turned on and running on the generator AC. If generator maintenance tests or repairs are required, the triple breaker switch is turned off manually, which disconnects the two phases of the generator from its branch, while making the stop button independent from the generator, thus allowing tests whether or not there is voltage in the power network, without the possibility of an undesirable coincidence between the power company network and the local generator due to human error. In the next video we will talk a bit more about the protection circuits which prevent the simultaneous activation of both power buses.
I hope this video has been useful to you. Thanks for watching and please subscribe to my channel. Shava ta'in.